Record it. Hi, everybody. Mark Fielder here. Today we're going to talk with Kevin Main and Ross Whitney from Torus Power. We're going to talk about building a power foundation for high-performance home theaters. We're going to record this message and we'll get it posted up to the website and the Fielder Marketing Facebook page. You'll be able to find us there if you go to fieldermarketing.com. Let's get going. Kevin, go ahead and you can share your screen and let's learn all about it.
All right. Good morning, everybody. I'm Kevin Main, and Ross Whitney is here also. Ross, you want to say hi?
Good morning.
So we're with Torus Power. We're going to talk to you about clean power for high-performance AV systems this morning. So what we've got set up here is a very short PowerPoint, probably about 10 or 15 minutes. Lots of time for some discussion, questions as we go, and then we'll get you on to your stuff that you need to do today. So we won't take too much of your time. Thanks for signing on this morning. So what we'll do is we'll start with I've only got about 5 slides to share with you today, and I'll talk a little bit about the stuff in the background. But we want to start off with the first kind of five points, if you will, for how to set up a clean power system for high performance AV systems. And the first is talking about system reliability. So, you know, how does a clean power add reliability to an AV system? Most people understand that there are many problems on the incoming power line. You've got, you know, noise, distortion, artifacts, atmospheric events that can all cause problems with the operation of sensitive electronic components. Well, can clean power really help products perform better and work more reliably? And the answer to that is a resounding yes, it can. So let's explore this a little bit more. Torus Power is the world's leading company on clean power delivery for AV systems through our fundamental technology of toroidal isolation. Toroidal isolation is the process of using magnetics to electrically disconnect your AV system from the incoming power and providing a clean power source to the components in your AV system. So let's show you here in the drawing. You'll see the red primary winding. This is the input voltage that's coming in from the location. It's wrapped around a transformer core in the picture here, and it energizes the transformer core. The blue winding is the secondary winding that picks up the energy and outputs it to the connected components. So you'll see in the picture that there's no connection between the incoming power and the secondary winding that's going to the AV equipment, and that's you know, that's really where we do our thing in the Torus Power isolation transformer. So you're physically disconnected from the input voltage that's coming into the environment. So using an isolation transformer can add reliability to your system in a couple of ways. The first is operational reliability, and that would be considered stuff like communication between components that's not being disturbed by power line issues. So flawless operation of keypad controls and microprocessors. And the second way that it adds reliability is in long-term equipment reliability. When the power supplies in the equipment are trying to compensate for electrical issues, they heat up and it shortens the life of the equipment. And that leads to microprocessor and power supply failures over time. Toroidal isolation is the most effective way of eliminating power line problems and providing a clean power platform for your high performance AV system. So then we'll move on to part 2, which is our automatic voltage regulation. The automatic voltage regulation deals with fluctuations and inconsistencies on the incoming power line. Things like surges, spikes, over voltage, under voltages, sags, transients. These are all problems that can occur in the electrical voltage supply that can cause problems or failures in system components. When the power supply in an electronic component that is not designed for a wide voltage fluctuation is asked to compensate for this, it creates heat that can shorten the life of the component. Regulating the voltage powering the sensitive equipment can solve this problem and add years of life to your components. So here's how we deal with the problem. We accept, in our automatic voltage regulation units, we accept an input voltage that ranges from 85 volts to 135 volts. There's an automatic shutdown when the voltage exceeds the thresholds and an email notification, and an automatic startup when the voltage is back within the normal threshold. Now, it takes this 85 to 135 volts and it'll regulate the output voltage to between 100 and, well, it's actually 116 to 124 volts now. We've made some modifications to the voltage. So how do we do that? So the way that we do that is through a transformer that has multiple input taps. So if you think back to the first picture with the transformer, you've got the input winding and the output winding. The input winding, the length of the input winding and the length of the output winding in relation to each other will determine how much voltage passes on the output. So for example, if you've got a 240 volt transformer on the input side, but you're outputting 120 volts, what people would call a step down transformer. This is done by regulating the size of the output winding compared to the input. So what we do on the automatic voltage regulation units is we have different starting points or different input taps on the primary winding. So we can change the size of the primary winding in relation to the secondary winding. We're looking at the voltage that's coming into the environment and changing the input tap with a series of relays to make sure that the output voltage is a consistent and stable 116 to 124 volts, as I mentioned before. And this is our automatic voltage regulation system. So that's the number 2 point for today's topic. The next is, let's talk about how to create a robust power ecosystem. So power and grounding are at the heart of any electronic system. Keeping distortion, harmonics, normal mode, common mode, noise to a minimum is necessary for reliable operation. To control power quality, we want to look at the source of the power and how it's being distributed to the system. Ideally, loads are going to be divided into 3 categories. Motor loads, and that's stuff like refrigeration, air conditioning, water pumps, things like that. Lighting and convenience loads. So think about, microwaves, coffee makers, lighting loads, dimming circuits, etc. And then the third is sensitive electronic, or what we call critical loads. And we want to isolate the control systems and audio video equipment from all of the other loads in the environment. We do this through a properly engineered and installed grounding system, a triple shielded isolation transformer with RF filtering and spike and surge protection, one larger transformer versus multiple power units in each rack. And the reason for that is the same ground potential and same phase of the electrical. A breaker panel with bolt-in breakers, copper bus bars, and isolated ground bar. Hospital grade receptacles, stranded wire to the receptacles, minimum 12 gauge to each 20 amp circuit. We of course recommend up gauging where possible. And you want to locate an isolation transformer as close as possible to the AV components, either the studio or theater applications. In that case, you want it to be less than 50 feet. And for audiophile applications, less than 20 feet. When you're adding and then we would suggest adding a UPS to protect network equipment and critical devices. And we're showing 2 pictures here for adding a UPS. The first is where you're adding a full online UPS that'll control and power the entire system behind the Torus Power unit. And the second is adding a UPS after the Torus Power unit, where you're just looking at some critical components like your network gear. So a couple different ways of wiring or setting up the system. In this case, your AV system is going to be isolated and conditioned. You're minimizing the number of different power sources, and all switching is done before isolation. In the second solution, you've got the optimized benefits of the AV electrical in number one. You're using a smaller UPS for sensitive devices that could lose data or be damaged on a hard shutdown. And you've got a direct line to the demanding components for the demanding loads. So that's topic number 3. The next one is talking about power as a foundational product, or how power is really a foundational product. But when it comes to AV systems, we really have to consider that every component in the system is powered by electricity and subject to noise and other problems that exist on the power line. We know that isolating the AV system from the electrical grid provides increased reliability and better performance, but let's take that a step further. Every high-performance AV and control system needs 2 well-designed systems for flawless operation. Number 1 is the network. But we can easily imagine the operational problems we would have by using a flawed network system for control operations. To avoid these problems, you want to start with a robust network system. The second is electrical power. Noise and other problems on the electrical line can cause operational problems, system reliability issues, and even component failures. We can eliminate these problems by isolating the power that's feeding the AV and control system. So let's think of it in terms of building a house. A well-built house starts with a strong foundation. When designing the foundation of the house, we try to keep water from damaging the building by using proper grading, waterproofing the exterior walls of the foundation, and using drainage towels to move water away from the foundation. We kind of take a similar approach to high-performance AV and control systems. Using a robust network and power isolation as the foundation for a high-performance AV and control system means reliable operation, long-term system reliability, and ultimately a happy customer. So always think about power and network as belonging at the front of the quote. When you're doing a project quote for somebody, because everything will work better with clean power and a solid network. The last part is how to specify power in a system proposal. When we're specifying the power for a high-performance system in a project proposal, we want to start by asking a few questions. First is, do you know the total load demand and total signature of the equipment that's being installed in the project? Have you completed an analysis of the power requirements of the equipment to determine the power delivery requirements? Number 2 is, have you completed a review of the electrical system in the project location? Do you know what needs to be done? Are there special electrical requirements that need to be installed to handle the load demand that you're going to be installing? Well, it may seem enough to simply supply the system with several dedicated 20 amp circuits to run the AV. There is more if you intend to deliver a high performance result. Care needs to be taken to minimize the distance of wire runs that can increase impedance or inject EMI or RFI noise and interference into the system. In addition, one single clean power source that can handle the full power load will ensure the proper reference to ground and ensure that the equipment is operating on the correct phase of the electrical for optimum performance. We can help you do this by completing a power analysis of your AV project before you specify the solution. Torus Power will review the system components being installed to determine if the overall system power demand and present options for the best performance and configuration. So taking the right steps at the beginning of the project will help ensure the best result at completion. Now, Ross is on the call, and maybe I can turn this over to you for a second, Ross, to talk about some of the things that you look at when you're doing an AV system power analysis.
Okay. First of all, I think the most important thing is to differentiate between dynamic loads and static loads. So an amplifier a powered subwoofer, even a projector or a display can be considered to be a dynamic load because they don't draw the same amount of current all the time, in most cases, at least. A Class A power amplifier would be an exception. You turn that sucker on and it's drawing its full power, even if there's no music playing. But that is an exception. And in most cases, an amplifier will be a dynamic load. Static loads would be things like source components, preamplifiers, control equipment, that sort of thing. So in order to do the load calculations, I'll have a look at specification sheets, owner's manuals, rear panels, fuse values. Some manufacturers are very generous with the power consumption information for equipment. Some of them are less generous, but there's usually useful information to be found. Sometimes the specifications will tell us if a component requires voltage regulation or not. Look at power amplifiers like the Crown DCIs or the JBL synthesis amps, and they're quite as happy running on an 85 volt supply as they are on a 240 volt supply. So for a component like that, we don't really need automatic voltage regulation. So we'll look at the individual components, calculate a preferred current allowance is the term that I use to figure out, what's going to make this component perform the way that it was designed to perform, 100%, no compromises, and take all those current figures, add them up, and that gets us one big step closer to specifying the best Torus power transformer for the job.
All right, thanks, Ross. So there you have, some quick tips on how to provide clean power for a high performance AV system. We've tried to keep it, short and concise for you this morning. But happy to answer any questions or have any discussions that you might have at this point.
Hey, Kevin, this is Mark. Can you give me kind of a brief reason why a 240 volt step down transformer here in the US it might be an advantage over a 120 to 120 type transformer?
Sure, absolutely, Mark. So in much of what we do, we use 240 to 120 step down transformers in a lot of our products. There's a number of reasons why you would want to do that. First is the size or the capability of the transformer that you can use. So if once you go from 120 to 240, you've got a lot more power capability to use a larger transformer. At 120 volts, you're maxed out at a 20 amp transformer, and a number of systems will require much more than a 20 amp transformer to do the right job. So you've got a higher capability available to use in a larger transformer. The second is that you can also use a balanced transformer, which we do in our 240 volt units, to eliminate additional noise that's present on the voltage line. We use a balanced input on our transformers. So we take the 240 input, we'll balance that on the input side, and then we still have the transformer, which is doing the noise filtering through our NBT noise filtering to eliminate even more noise that's present on the voltage line. It's always just, I think, a best practice to be using a step-down transformer. It's more, it's going to be more reliable. It's really going to be a better starting point for you for the AV system, giving you more capability and giving you a little bit more noise reduction capability than a 120 volt transformer.
Right.
Yeah.
Hey, Ross, would you be able to help out our dealers with how to basically, what kind of plugs to use and what kind of wiring to use to pre-wire for a Torus power unit?
Absolutely. Yeah, at all times.
Okay, great. Anybody who's on the webinar with us, you'll have to unmute yourself or ask to unmute it if you have any questions for Kevin or Ross.
I'll break the silence by mentioning that if anyone needs, any kind of tech information, the easy address to reach me on is just tech, TECH @toruspower.com. Oh, there's some more.
There we go. Here's how to reach everybody.
Hey, Mark, I have a quick question.
Go ahead.
We have used balanced power systems for a number of years on higher performance systems. And what we like to do, of course, in video distribution is try to get the TVs on the same ground plane as the head-end gear, right? Sources and distribution equipment.
Sure.
Question I've got is, obviously, if you've got a centralized Torus power unit someplace, some of the runs in these bigger houses are going to be pretty substantial in length. Like the Romex output side of the Torus power unit might be 200 feet to get to the farthest television set that's on the balanced power system. And the question I've got, obviously we do that in 12 gauge to maintain the 20 amp thing all the way through. But is there any negatives? Are we creating more problems than we're solving by doing that kind of wire length or not?
Hey, Ross, this might be a good question for you.
Okay, yeah, great question. The first thing that comes to mind is that a display isn't really a demanding load in the way that a power amplifier would be. So one of the issues with a long wire run is that there is some resistance. The wire does present some resistance, which can limit the instantaneous flow of current to a load like an amplifier. But for a display, a TV, or even if it's a projector, the voltage drop and the limitation of what instantaneous current might be available isn't such a problem. And if you're using cabling that has, that's inside of a metal conduit, then that should minimize the pickup of radio frequency and electromagnetic interference. So we don't, the benefits that we gain by having the same ground connection to all of the components, and by the way, the same neutral connection as well, because when on the output side of our transformer, we do bond neutral and ground together. So the benefits that we gain from using the Torus transformer really outweigh the downside of a long wire run.
Great answer. Thank you, Ross.
Thank you.
Hi, this is Jason Wright. I have a quick question. We have a client that's kind of an audio nerd and has gigantic amplifiers for his 7.1 system, and they're planning the electrical right now. Is there any reason to do something more robust than 20 amp circuits, say like 30 amp circuits, or something else that we should be thinking about now from an electrical rough-in perspective?
Well, it really depends on the component. I mean, there are some amplifiers, some mighty amplifiers that can run on 120 or 240 volts. So if you give the amplifier 240 volts, then as a general rule, it will have more power available to it and it will perform better. I mean, that's not always the case, but in general, 120 volt equipment, a 20 amp circuit will be enough for any 120 volt component, unless you're charging a Tesla or something. But yeah, as a general rule, 20 amp circuits should be fine, but you may need a bunch of them, especially with immersive audio.
Hey, Jason, this is a good opportunity to go ahead and reach out to Ross on your project specifics. And they can walk you through what kind of power you might need for this.
Yeah, please do.
Great, thank you.
You bet.
Yeah, one thing I can just add to that, Mark, is when you're getting into a larger system for somebody that's an audiophile, the load requirement may far exceed 20 amps. And when you're saying put in a 20 amp circuit or a 30 amp circuit, I mean, we see projects where we're putting in 100 amp feeds to the audio gear or even beyond that. So it could easily be that the equipment demands much more than 20 amps or even 30 amps. And Ross can help guide you on that. If what Ross needs from your end would be a list of the components that are going to be used in the install. and then Ross can go to work and come back with some recommendations on, you know, how much power do the components really need in order to operate the way that they're designed to operate.
Right.
That's a good starting point for us.
For sure.
And yeah, the list should ideally be as complete as possible. Like even though a loudspeaker doesn't have a power plug, it still does have an impedance, and power amplifier is going to be able to deliver more power into a 4-ohm speaker than it can into an 8-ohm speaker. If the power amplifier is delivering more power, that means it's going to draw more power as well. So the more information I have, the more thorough I can be with the current calculations.
You guys said you were going to put this recording up on your site so we could theoretically take this information and send it to a tech-loving customer to understand what he's buying.
Absolutely.
All right.
There is a bunch of information on our website as well. You know, you're welcome to share that information with your clients. And this particular discussion that we're having today, we've been recording this in different sections, and it'll be up on our website over the next few weeks as well.
All right. Well, I think we've spent our time, our 30 minutes. So thank you, everybody. If there's no more questions, I'm going to go ahead and end the recording now.